Hello everyone. In this video, I am going to give you a presentation on Introduction to Sedimentary Rock. First of all, what do we know about sedimentary rock? Well, sedimentary rocks are formed by the consolidation of sediments and produced by erosion of pre-existing rock materials and also by precipitation of minerals from water. Moreover, they are the types of rock that are formed from pre-existing rocks or pieces of once living organisms. They are also formed by the accumulation or deposition of mineral or organic particles at the Earth's surface. The particles that form a sedimentary rock are called sediment. So, we can say, sediments are fragments of rock that have been broken down as a result of weathering by wind, ice, running water and more. These rocks are also composed of geological detritus like minerals, or biological detritus, organic matter. Sedimentary rocks are formed through a series of processes that occur in different stages as sedimentary rocks are derived rocks or secondary rocks. The first stage in the formation of sedimentary rocks is weathering. It involves the breakdown and disintegration of rocks and minerals at or near the Earth's surface due to exposure to physical, chemical, and biological processes. Once the rocks and minerals are weathered, they are eroded and then transported away from their original location by agents. After transportation, the sediment is deposited in a new location. Deposition occurs when the transporting agents lose their energy and can no longer carry the sediment. Over time, the layers of sediment undergo compaction. The weight of the overlying sediment exerts pressure on the lower layers, squeezing out the air and water between the particles. This pressure causes the sediment to become more tightly packed, reducing the pore spaces between the grains. As compaction occurs, the sediment particles come into contact with dissolved minerals in groundwater. These minerals precipitate and fill the remaining pore spaces, binding the sediment particles together. This process is known as cementation and results in the formation of a solid sedimentary rock. The combination of compaction and cementation leads to the lithification of sedimentary rocks. Lithification is the process by which loose sediment is transformed into solid rock. The sedimentary rock becomes consolidated and hard, forming distinct layers or bedding planes. However, diagenesis refers to the chemical, physical, and biological changes that take place in sedimentary rocks after they have been lithified. It can involve processes such as recrystallization, mineral growth, dissolution, and the introduction of new minerals. Diagenesis continues to modify the sedimentary rock over time, even after it has been fully formed. These stages illustrate the complex process of sedimentary rock formation. Now, question is, where are the sedimentary rocks formed? Sediments are deposited on beaches, deserts, at the bottom of oceans, in lakes, ponds, marshes and swamps and many more. However, sandstone, shale, and limestone are the most common types of sedimentary rocks. 95% of all sedimentary rocks consist of sandstones, mudrocks or shale and carbonate rocks. Of these, the mudrocks are most abundant, making up about 65% of all sedimentary rocks. Sandstones make up 20 to 25%, and carbonate rocks account for about 10 to 15% of all sedimentary rocks. Next, how do we classify sedimentary rock? A very basic classification of all sedimentary rocks is based on the type of material that is deposited, the size of sediments, the texture, and the modes of deposition. We can classify sedimentary rocks in clastic rocks and chemical and organic rocks. Furthermore, chemical and organic rocks include evaporite rocks, carbonate rocks and organic rocks, where evaporite rocks are formed due to evaporation from saline water, for examples, gypsum, halite, rock salt. Carbonate rocks form basically from calcium carbonate by both chemical leaching and by organic source. For examples, limestone, dolomite. Organic rocks. Organic rocks form due to decomposition of organic remains under temperature and pressure. For examples, coal and lignite. Shale, sandstone, breccia, conglomerate are some of the detrital sedimentary rocks. These rocks can be identified by composition and texture property that are given in this table. However, shale is formed by clay-sized particles that cannot be differentiated by the naked eye. It is fissile and splits into distinctive layers. Sandstone is composed of sand-sized particles that can vary in mineralogy, including mainly quartz, feldspar. Breccia is poorly sorted, and it is mixture of rock fragments including angular or subangular pebbles. Next, conglomerate is poorly sorted mixture of rock fragments, including rounded or subrounded pebbles. There are some chemical and biochemical rocks which are limestone, fossiliferous limestone, oolitic limestone, chert and rock salt, which can be identified by its given chemical composition and textual property. For example, limestone can be identified by having masses of large interlocking calcite crystal, or microscopic crystals that are not busy with the naked eye. Fossiliferous limestone consists of fossils or fossil fragments. Oolitic limestone is aggregate of oolites, small spherical calcite concretion. Other than that, chert is microcrystalline polymers of quartz, formed by the recrystallization of siliceous skeleton. Rock salt is fine to coarse-grained crystalline structure with a salty taste and cubic cleavage. Now, let's discuss in details. Sandstone is a sedimentary rock composed of sand-sized grains of mineral rock. Sandstone may contain a matrix of silt or clay-sized particles that occupy the spaces between the sand grains. It is one of the most common types of sedimentary rock. The four common types of sandstone are quartz-ehrenite, arkose, lithoronite and greyvac. Another rock, shale, is fine-grained, siliciclastic sedimentary rocks, composed mainly of particles smaller than 62 microns, make up approximately 50% of all sedimentary rocks in the stratigraphic record. Average shale contains about 2 parts silt and 1 part clay. Conglomerate are siliciclastic sedimentary rocks that consist predominantly of gravel-sized clasts and which are composed mainly of rock fragments rather than individual mineral grains. The gravel-sized material in conglomerates consist mainly of rounded to sub-rounded rock fragments. By contrast, breccias are aggregates of angular, gravel-sized fragments. There are two types of conglomerate, orthoconglomerate and paraconglomerate. Next, limestone is a sedimentary rock composed primarily of calcium carbonate, CaCO3, in the form of the mineral calcite. It most commonly forms in clear, warm, shallow marine waters. It is usually an organic sedimentary rock that forms from the accumulation of shell, coral, algal, and fecal debris. These mostly form in shallow marine depositional environment. They serve as reservoir rocks for more than 1/3 of the world's petroleum reserves. Moreover, coals are a carbon-rich type of carbonaceous sediment. They are composed dominantly of combustible organic matter but contain variable amounts of impurities, ash, that are largely siliciclastic materials. Coalification refers to all the processes that take place when peat is converted into coal. However, sedimentary rocks are characterized particularly by the presence of layers, by distinctive textures and structures, by their mineral and chemical compositions and fossil content. Sedimentary rocks cover roughly about 3/4 of Earth's surface. The area of Earth's surface covered by sedimentary rocks has increased progressively with time, as the area of volcanic rocks has been successively reduced by erosion. The layers are called strata, or beds, are probably the most characteristic feature of sedimentary rocks. Sedimentary rocks and sediments range in age from Precambrian to modern. The ages of the oldest known sedimentary rocks, in Greenland and northern Quebec, Canada, have been determined by iron isotope analyses. Furthermore, sedimentary rocks display certain characteristics that allows draw conclusions about the history of landforms and rock formations. One such feature is bedding. This is the result of sediment settling out in large areas. Each bed tells a story about the conditions in which it formed. Sedimentary rocks are so useful because they record the Earth's history, what kind of environment was where and when. They are the primary storytellers of past climate, life and major events at Earth's surface. In conclusion, the main stratigraphic unit of a sedimentary rock is a formation. The deposition of sedimentary rocks can be described in terms of a series of principles, including original horizontality, superposition and faunal succession. These rocks can also have distinctive structures that are important in determining their depositional environments. Fossils are useful for determining the age of a rock, the depositional environment, and the climate at the time of deposition. Maturity in sediments refers to the extent to which sediment characteristics reflect prolonged weathering and transport. Degree of roundness helps in knowing the distance of transportation. Sorting of the sediments also suggests the mode of deposition and transportation. If this video seems helpful to you, please like and subscribe Earth Detective, and also visit our YouTube channel where we uploaded lot of videos based on earth science. We also organized the videos in playlists based on topics. Feel free to explore and suggest us what you want to learn. You can also check description for links of our social media, website for resources, PowerPoint file and further discussion. Thanks for watching.